Okie dokie, artichokes. Here we have the review for our rational functions. And these first groups of problems are wanting limits. And the first thing is to notice where the limit is going. So here we're asked for a limit to infinity. So you need to know a limit to infinity is asking for a horizontal asymptote. Okay, so it's either top heavy and we don't have one, or it's bottom heavy and it's 0, or it's neutrally heavy, and then we have to look at the coefficients. So as we look at number 1 here, we notice that we have an x in the top and an x on the bottom. Hopefully you notice that. So this is a neutrally heavy rational function. So we look to the coefficients. So our x on top has a coefficient of 2, and our x on the bottom has a coefficient of 1. So 2 divided by 1 is 2. Now, what does that mean for our graph? Right? That means that we have a horizontal asymptote at y equals 2, as was said earlier. Perfectly well done. Okay, let's move down the page rather than across. Let's go down the page. Here we have another limit as x goes to infinity. Okay, so we're looking at top heavy, bottom heavy, or neutral. And I hope you notice this is a neutrally heavy function. So you look at your coefficients, which in this case are -3, right? Keep the minus sign with it, and +1. So the answer is -3. And what does that mean for our graph? That means there is a horizontal asymptote at y equals -3. Okay, so every time we're looking at a limit to infinity, we're asking for a horizontal asymptote. Here is a third example of a limit to infinity. Okay, so we look at the x on top and x cubed on the bottom. So hopefully you recognize this one as being bottom heavy. And bottom heavy answers are always 0. The answer is 0. The answer to the limit is 0, which means for our graph we have a horizontal asymptote at y equals 0. So let's look at these other sets of problems. This one, we have x going to a number. Okay, so when x goes to a number, we want to try and do direct substitution, which means you take your 5 and you plug it into here. Okay, so let's do our work in the garage. So let's work down here. When we plug 5 in, we get 10 minus 9 over 5 minus 5, which is 1 over 0. Now, this should give you the clue that the limit does not exist. Okay, if when you use direct substitution, you plug in your value and you get a number over 0, that means the limit does not exist. And for the graph, we have a vertical asymptote at that x value that you tried plugging in. Okay, so if this number is x goes to 5, then our equation is x equals 5, right? That's the equation of our vertical asymptote. Okay, let's see, what else do we have over here? Here's another one. Oh, this one looks similar, doesn't it? We're going to plug in 5 again into both of our x's, everywhere we see an x. So we have 2 times 5. I can do that in my head. I don't have to write it down. 2 times 5 is 10 minus 10 over 5 minus 5, which is 0 over 0. Okay, now this should tell us that our graph has a hole. And we have to do some more work in order to find the y value of that hole. Okay, so let's come over here and do our work in the garage. Okay, we need to factor this, so we factor to 2 times x minus 5 over x minus 5, and we get the answer of 2. Which is kind of strange, I know, but it means that no matter what the x value is, the y value is always going to be 2. So the answer to our problem is a 2. Usually that doesn't happen, right? Usually we get some type of an equation left over that we're going to plug 5 back into. But in this case, the equation is gone, so we're just using 2 as the answer. go. What does that mean for our graph? It means that we have a hole at the point 5, 2. Okay? The x value we're talking about is 5 from your limit, and the answer to our limit question is 2, which is the y value that you get for your hole. Okay, so let's plug in this one. This one is a 3. We can do this. I know we can. Let's see. Let's use green. Sure, why not? So 3 is going to go into both of these places. Okay, so let's come over here in the garage. 3 minus 3 over 9 minus 9 is once again 0 over 0. Okay, so that means that we have to factor. Now look at the top. It's a 3 minus x. So I'm going to factor out a negative, because chances are in the denominator I'm not going to have anything that cancels unless I change it into the x minus 3 form. Okay, but I need to have that negative out there. So my equation simplifies to negative 1 over x plus 3. Okay, if everything cancels out in the numerator, I have to have a 1 as my placeholder. Okay, so now when I plug in positive 3 again, I get negative 1 over 3 plus 3, which is negative 1 over 6. So the answer to my limit question is negative 1/6. And what that means is our graph has a hole in it at the point 3, negative 1/6. Okay, 3 from your x part, from the limit, and negative 1/6 from the calculation of that y value. Okay, so when x goes to infinity, you're looking at horizontal asymptotes, and when x goes to a number, you're looking at vertical asymptotes or holes. Okay, so remember to do your work on the side and then put just the answer after the equal sign. Because there's one other type of problem to work on, and that's these profile questions. Okay, we know it's a profile because we're looking at the plus. So we're looking at just from the right of positive 4 in this case. So the profile either goes up to positive infinity or it goes down to negative infinity, depending on the sign of your problem. So if we're going to go to the right of 4, that means we're going to plug in a number like 2.4. Okay, so let's come over here, away from our living room into our garage so we can do all the work. So 4.1 is a number a little bit to the right of 4. So we plug in 4.1. And this is 8.2 minus 5 over 0.1, which is, I don't know, 3.2 over 0.1, which is really not that important that the answer is 32. What is important is that the answer is positive. And with a positive answer, we can say that our graph profile is infinity, meaning that the graph goes up, right, up to infinity on the right side of x equals 4. Okay, so all we're looking for is whether this number is positive or negative. If it's positive, the answer is infinity, and if it's negative, the answer is negative infinity. So let's see what happens on our next question down here. Here we're plugging in negative 4 to the left, a number a little bit to the left of negative 4, like potentially negative 4.1, right? A little bit more negative, a little farther away from 0. So on the top, I get negative 4.1. And on the bottom, negative 4.1 squared plus 8 times 4.1, sorry, negative plus 16. Okay, so this is 6 positive, right? Negative 4.1 squared is positive 16 point something. Minus, this is 32.8 plus 16. Okay, so I have a 16 and a 16. Well, that's 32 point something minus 32.8. Okay, and chances are this is not a very big decimal, right? I have 4.1 squared. So 32.81 minus 32.8 is positive 0.01. But on the top I have a negative number, and on the bottom I have a positive number. So overall my number will be negative, because it's negative divided by a positive. Okay, so if I get a negative as my answer, then my limit is negative infinity. Okay, which means the graph goes down on the left of x equals negative 4. So what else do we have on here? I believe we have some horizontal asymptotes. Nope, slant asymptotes. So notice here that our graph is top heavy, right? We have an x cubed on top and an x on the bottom, which means we're going to have a slant asymptote. So we employ long division. How many times can x minus 4 go into 3x squared plus 2x minus 1? Okay, so our brain needs to think, by what must I multiply x in order to make it into a 3x squared? And hopefully you know that that answer is 3 times x. Okay, so when I do my distribution, I will multiply both of these things by 3x, get 3x squared minus 12x, and now I have to subtract. So that's a minus 3x squared, but now it's a plus 12x, giving me 14x, and then I drop down the minus 1. Okay, where I ask myself again, x squared times what is 14x? And the answer is plus 14. Okay, now I don't have to do anything else because I now have my slant asymptote. 3x plus 14 is the equation of my slant asymptote. Okay, and we can do a similar thing with this one over here, remembering that since we don't have an x in here, we're going to have to put a 0 as the placeholder when we do our long division. So when we long divide, we end up getting y equals x plus 1/2 as the slant asymptote. Okay, our next section is finding intercepts. So to find the y-intercept, you just plug in 0 for x. Every x you see, you put a 0 in there for. And for the x-intercept, we have to solve the numerator. Solve the numerator. Okay, so there you see all of your functions. Why don't you pause the video and try and do that, and then come back and see if you got it right. So there are all of the answers. Your y-intercept, you plug in 0 for all the x's and you simplify. And for the x-intercept, you solve the numerator. So sometimes we have to factor, sometimes we factor and cancel, sometimes we just use our amazing brains. Okay, so our last one, our domain, right? We have to use solve the denominator in order to find your domain. So x squared minus 5x cannot be 0. So x and x minus 5 cannot be 0. So x can't be 0 or positive 5. Okay, so we have to do a similar thing that we did up a little bit ago. We're going to take 0 and plug it in here. And when we plug in 0, we get 5, right? Negative 5 on top and 0 on the bottom. Okay, so that tells us that we have a vertical asymptote at x equals 0. Okay, that's your vertical asymptote. And the other one is if we plug in positive 5, we get 0 over 0. So that means we also have a hole. Okay, and we have to do some investigating to figure out what that y value of the hole is. Okay, so we factor just like we did a second ago. We cancel out what we don't need, and we get 1 over x. So when I plug 5 into 1 over x, I get 1/5. So I have an asymptote at 0, and I have a hole at 5, 1/5. Okay, the y value is 1/5. Okay, Y-intercepts. When you plug in 0 for the x values, we get -5 over 0, so we have a Y-intercept at 0, 0. Which is strange. No, we don't. When we plug in 0, we get 5 over 0. So your Y-intercept is undefined. We do not have a Y-intercept. Okay, which makes sense because there's a vertical asymptote on the y-axis. And since our lines really cannot cross your vertical asymptote, that is okay. And do we have any x-intercepts? Looks like we have none. Okay, yes, when we solve this, we get +5, but remember x cannot be +5, so we have no x-intercepts either. Okay, which will make sense now that we talk about horizontal asymptotes. This is a bottom-heavy graph, so y equals 0 is your horizontal asymptote. Okay, so it won't cross your x-axis either. So if we put all this together in a graph, let's see if we can do this. We have a vertical asymptote through 0. So somehow let me know you have a dashed line here. We have a horizontal asymptote through 0 also. Okay, we have a hole at 5, 1/5. So 1, 2, 3, 4, 5, and then 1 that's really going to be really small in here. Basically there. So if we were to do a profile, right, and decide the profile, we're just looking at 1 over x as our profile. So if we plug in a number to the right of 0, that's a positive value. So our graph will be like this. Right, comes to your hole and then it jumps over there. So positive on the right and negative on the left. If we have a negative value, it goes down to -infinity. Okay, so that's where our profile comes in. It helps us to be able to sketch on what side of our asymptote does the graph live. So that's a pretty good looking one for that example. So here's another one where you're given an equation and you have to make a sketch by finding all of the attributes for it there. So pause it and see if you can do all of this on your own, and then come back in 4 seconds and see if you got it right. So there is your sketch. -4 intercept, -5/16 y-intercept, x at 5, 0, horizontal at y equals 0, and a vertical at x equals -4. Okay, now the rest of these are telling us what to sketch, and we just have to do our best to interpret the language that they're using. So here are your 2 graphs when we're given all of the attributes. Okay, find your intercepts, find your asymptotes, find your hole, right? The hole is if you have a discontinuity with the y value, and your vertical asymptote is where your limit does not exist. Okay, then the last 2 problems are solving, and we always solve by cross multiplying. So there are your 2 solving by cross multiplying questions. Okay, so notice on this right one you have an x squared on the right and an x squared on the left. Those both subtract each other, so you do not have an x squared anymore in your equation. Okay, so this is all things about your rational functions, from finding intercepts and asymptotes to solving rational equations and figuring out what the profile is around your verticals and whatnot. Lots of whatnot.